Do you ever think about what it would be like to travel through space or live in another planet? Outer space has captured the curiosity and imagination of humankind for thousands of years. From mapping the constellations, building telescopes, and writing science fiction, we have long dreamt of traveling among the stars. It has been less than 100 years since we sent the first satellite to orbit the Earth, and now in the 21st century, we are actively working towards the goal of settling life on other planets. From NASA's Artemis mission to Elon Musk's SpaceX, life beyond the Earth is now more than just futuristic stories. It is an attainable reality. So, for the purpose of this presentation, we want you to imagine a world where we have already established settlements on the Moon and Mars. A world where it's not just a single country, but multiple countries across the globe that have managed to implant living communities beyond the Earth. Managing and sharing resources will need a special approach. We know that it takes a considerable amount of time and money to travel beyond the Earth's atmosphere. So how will these communities be able to manage emergency needs? In space, the risks are high, the environment is unforgiving, and the consequences of failure are massive. Although different organizations will be competing for resources in these new worlds, there are times when they will need to collaborate and share resources. Because of this, co-opetition is the best way to sustain life in space. In the beginning of our settlement efforts, we know that robots will be essential to setting up habitation and operations equipment. In fact, the first few phases of NASA's Artemis mission focuses specifically on using robots to set up human habitation and operations on the Moon. Robots will record data about the environment, they will print 3D structures, and they will move materials from place to place. Many of these robots will be autonomous or require minimal guidance from human operators. Once we begin to live in these settlements, robots will still be needed to help manage construction, maintenance, and operations. But what happens when robotic assistance is needed and not immediately available? Settling organizations will need to be able to trade in order to survive, including trading the use of these robots. It's unlikely each organization that travels to these places will be able to bring a full portfolio of the equipment needed. But some of these organizations may be hesitant to trade with one another due to political and cultural differences originating from Earth. A system is needed to provide transparency to all involved parties, one that's going to be efficient, cost-effective, and reliable. To address this challenge, we have created Autobots Equipment, a blockchain-based equipment library that allows users to rent time on robots in order to complete critical tasks. Imagine an Uber application where instead of renting a driver, you rent a robot to move supplies from one point to another. Let's pretend you are a settler at a government-sponsored lunar colony, and one of your solar panels have been hit by space debris. You need to make repairs and you have the materials, but they're stored in an off-site warehouse, and that would require you or a coworker to suit up and go across the lunar surface. This would expose you to radiation, space debris, and extreme temperatures. Any technical difficulties or equipment malfunction could result in major injuries or even death. Your team has access to autonomous rovers that can complete this task for you, but they're working on other critical missions. So, you want to find out if anyone else on the Moon has a rover available for you to rent. In a case like this, Autobots Equipment would provide access to a library of available rovers in your area. Accounts are set up using self-sovereign ID for users, renters, and robots. Once your account is set up, you will have access to a variety of robots available for rent, or you can list a robot of your own on the network for others to use. You can direct your search by task, location, and renting company. Prices for rentals are provided up front, as well as availability and user rating. Once you've provided the application with rental parameters, like the pickup location of your repair equipment, security clearance, and delivery location, you'll be able to track the status of your order by GPS, check calls, and delivery confirmation. Once your repair equipment is delivered, its delivery is closed and you are charged for the rental. Other tasks will be available on the network, such as 3D printing jobs at regional factory locations, drone usage to stand in new areas, and building construction. The Autobots Equipment Library is designed to be transparent, trustless, and efficient. Because it is stored on the blockchain, the data is encrypted and resilient to attacks by bad actors. By utilizing satellites to power nodes, our application removes the location barriers and allows users around the world and on other planets to access and use it. Operators from Earth-based locations can order equipment rentals remotely, without having to be physically located on the Moon or Mars to carry out missions. Data derived from these transactions can help robot owners better understand how their robots are being used and how they perform. This data will also help users make smarter decisions on which robots to rent in order to best meet their needs. Our application will be powered by Qtum, a blockchain-based application platform that combines elements from Bitcoin and Ethereum. It's based on the proof-of-stake protocol and has the ability to host smart contracts. The nodes in the network will be powered by orbiting satellites hosted by SpaceChain, a blockchain satellite network company. Satellites will be placed in orbit all around planetary bodies that utilize the network to ensure the ability for all users to connect to it. Robonomics, an open-source blockchain platform that allows users to connect their robots to digital markets, will be utilized to connect the robots on the platform to end users. Their AI-first approach is designed to utilize automation technologies to drive building business processes that scale to the individual business needs. MongoDB will host the off-network databases. This is where information about the transactions, as well as data that can be used for machine learning and data analysis, will be stored. Users and robot owners will be able to view data points like average job time, task success, and average payload. This information can help users better determine which companies use for rentals and can help renting companies improve their robots' performance. To manage the network, stakeholders will form an advisory board based on their stake in the application. They will manage the implementation of smart contracts between users and updates to the network. Entities like NASA, Roscosmos, SpaceX, and others currently working on settlement efforts will be able to collaborate to determine the rules of using the network. Rules from treaties between countries, as well as international space regulations, can be built in for smart contracts to provide a layer of trust between each user party. Several initiatives have begun by government and private organizations to begin settlement on the Moon and Mars, with players like NASA, SpaceX, Russia, China, and various other public and private entities. They will need sophisticated technology, software, and operational processes in order to reduce the risk of settling life off Earth. Our ability to manage our resources and these risks will determine the success of these missions. To settle on another planet or moon is arguably one of the greatest challenges mankind has ever taken on, and it will require that we collaborate and pool resources in order to be successful. Our Autobot equipment library will help remove barriers that currently exist within this challenge and empower those who settle on new worlds to not only survive, but thrive.